Let's just dive right into this. Welcome, young scientists and junior detectives, to today's Explainer. Today, we're opening up a massive, literal, planet-sized investigation into one of the wildest mysteries on Earth. We're calling it the Great Ocean Mystery, and we're going to crack the case of the salty sea. If you love figuring out how our world actually works, you're in the exact right place. So grab your imaginary magnifying glasses, because we're going to look at the clues, examine the evidence, and solve a puzzle that's been brewing for, well, billions of years. To kick off our detective work, we've got to start with a really brilliant question. Have you ever wondered why the ocean is incredibly salty, but rivers and streams totally aren't? I mean, if you've ever accidentally swallowed a gulp of seawater at the beach, you know exactly what I'm talking about, right? Yuck. It is super salty. But if you go swimming in a river or a lake, the water's fresh. So, where in the world does all that ocean salt actually come from? And just to show you the massive scale of the mystery we're dealing with here, check this out. A whopping 97% of all the water on planet Earth is saltwater. 97%. That leaves only a tiny little 3% as freshwater. Almost all the water on our entire planet is completely filled with salt. That means we aren't just looking for like a little sprinkle of salt, we are looking for an absolute mountain of it. Now, here's a crazy clue. When the Earth first formed, which was about 4.6 billion years ago, the ocean was actually only a little bit salty. The water originally came from deep inside the Earth, kind of bubbling up to the surface as steam and gas. But that early water, it wasn't packed with the salt we see today. So clearly, something changed over those billions of years. The famous fictional detective Sherlock Holmes actually once said that from a single drop of water, a really good thinker could guess the existence of whole oceans. And you know what? That's exactly what we are going to do today. We're going to act like scientific logicians. We are going to use the tiny clues hidden in a drop of water to solve where the ocean's salt came from. All right, let's bring in our very first major suspect in the case of the salty sea. Suspect number one is actually a dynamic duo, the rain and the rocks. I know, it sounds a little bit crazy, like how can rain and rocks make the ocean taste like a giant salt shaker? Well, the answer lies in some invisible chemistry happening right above our heads. Here is that secret chemistry in action. So as rain falls from the sky, it actually collects carbon dioxide from the air. This turns it into a super weak, invisible acid. And when this slightly acidic rain hits the ground, it literally eats away at the rocks. It breaks them down and releases these tiny bits of minerals called ions, specifically things like sodium and chloride. Then, the rainwater washes these tiny ions into streams, and the streams carry them to the rivers, which flows straight to the sea. And when sodium and chloride get together, boom, you get salt. But wait a second. This presents us with a really glaring clue. If the rivers are basically the delivery trucks carrying all these salt ingredients down to the ocean, why aren't the rivers themselves salty? Like we said earlier, if you take a sip of river water, it tastes totally fresh. This seems like a giant hole in our investigation, right? Well, here is the big secret. Rivers actually do have salt in them, but in such incredibly tiny amounts that your tongue can't even taste it. Think of it this way. Imagine if you brought just one single grain of salt to your school. No one would even notice it, right? But what if every single student in every single school, in every single country, in the whole world brought just one grain of salt to school? You would end up with a gigantic mountain of salt. And that is exactly what happens with rivers. Every river on Earth empties its tiny, unnoticeable bits of salt into the ocean. And because the ocean is the end of the line, it just stays there. And over time, those tiny bits add up. And oh boy, do they ever add up. Try 4 billion tons. To put that into perspective, that is heavier than 10,000 Empire State Buildings. The rivers of the world dump that much dissolved salt into the ocean every single year. Year after year, for billions of years, those delivery trucks have been dropping off their invisible cargo. Actually, let's paint a picture here. If we could somehow magically pull all the salt out of the entire ocean today and just spread it evenly all over the land, kind of like you'd spread peanut butter over a piece of toast, it would create a layer 500 feet thick across the entire Earth. That's almost as tall as the Washington Monument. Imagine that, just a giant 40-story tall wall of solid salt literally everywhere. But hold on, our investigation isn't quite over yet. The rain and the rocks didn't act alone. We need to move our detective work from the land down to the very bottom of the sea to find our next suspects. So let me introduce suspects number 2 and 3, the underwater accomplices. Our second suspect is something called a hydrothermal vent. Now, a hydrothermal vent is basically a bubbling hot hole in the deep ocean floor. What happens is ocean water seeps down into the rocks at the bottom of the sea. Then, the Earth's super hot core heats that water up, and the hot water dissolves minerals directly from the rocks down there. Finally, that mineral-rich hot water shoots back out of the vent like a geyser into the ocean, bringing loads of extra salt right along with it. And usually, right next to those vents, we find our third suspect, underwater volcanoes. It's really the same kind of extreme chemistry. Searing hot lava erupting from underwater volcanoes reacts instantly with the freezing cold seawater. This intense reaction dissolves even more minerals from the newly formed volcanic rocks, releasing massive amounts of salt directly into the water. Okay, so we've totally cracked where the ocean gets its salt. It's a team effort, but let's take this investigation to its absolute thrilling climax. Let's look at what happens when this whole salt-making process goes to the extreme. We are going to travel to a very famous lake on Earth called the Dead Sea. So regular ocean water is salty, sure, but it's completely full of life, right? Seaweed, fish, dolphins, you name it. But the Dead Sea? Well, it's called dead for a reason. It is nearly 6 times saltier than the regular ocean. It's so packed with dissolved minerals like magnesium, calcium, and potassium chloride that absolutely zero plants or fish can survive in it. Literally nothing. But why is it so extremely salty? To understand why, we've got to look at its geography. The Dead Sea is located over in the Middle East, right between Jordan and Israel. Rivers, like the Jordan River, flow into it, bringing all those tiny grains of salt we talked about earlier. But here is the ultimate trap. No river flows out of it. It has 0 exits. The water and the salt are completely 100% trapped. So you might be thinking, if water keeps pouring in from the rivers, why doesn't it just flood over? The answer is evaporation. That's the process of water heating up and turning into an invisible gas in the air. The Dead Sea sits in a really hot desert, so the water evaporates super quickly into the sky. But the salt? The salt is heavy, so it gets left behind. Because the Dead Sea loses water to the hot sun, but keeps all the salt brought in by the rivers, it literally just gets saltier and saltier and saltier every single year. And because of all this leftover salt, something honestly kind of magical happens regarding density. Density is basically just how heavy and tightly packed something is. Because the Dead Sea is so unbelievably jam-packed with dissolved heavy minerals, the water itself becomes incredibly dense and heavy. And because of that crazy high density, you literally cannot sink in the Dead Sea. I'm not kidding. To float, an object has to push aside water equal to its own weight. Because Dead Sea water is so heavy and dense with minerals, your body is instantly pushed right up to the surface. You could just bob around like a log, flip onto your back, and comfortably read a comic book without ever even trying to tread water. It's basically like swimming in an anti-gravity pool. So detectives, we did it. We've officially solved the mystery of the salty sea. It's all about the rocks, the rain, the rivers, deep sea vents, and the awesome power of evaporation. To wrap up our explainer today, I want to leave you with a quick question to test your new detective skills right in your own neighborhood. Next time it rains and leaves a big muddy puddle on your driveway, watch what happens when the hot sun comes out. What do you think happens to the water and what gets left behind? Think about the Dead Sea, and I bet you'll have your answer. Keep asking questions, keep investigating, and we'll catch you on the next explainer.